math. I am going to be on page in your notebooks, if you wouldn't mind getting them out. I am on page 59, 59, page 59. All right. Page 59. Everyone there? All right, all right. All right. So, chapter 8 says, consider a research study that wishes to test whether the experimental medication to reduce chronic migraine pain helps. Oh, this might be a study some of you who get migraines might be interested in. I don't know if this is a true or false study, but let's just pretend it's true. Since the entire population of migraine sufferers will not be able to participate in the study, we inherently need to find a small subset of this population. Will the results of our study be applicable to the population at large? Will using a small group of the population produce results that will be useful to researchers? All right. It says statistical issues surrounding this kind of sampling are significant and need to be explored. First, an array of terms needs to be defined. So population of interest is the entire group we wish to study. So population of interest in this one, you would just squeeze this over there. Pop of interest, migraine people, migraine. Did I spell migraine? Migraine sufferers. Okay, so our sample, you can see it. Our sample, we're on page 59 when you get settled. Our sample is going to be a portion of the people with migraine pain. That's for the final, so it gives you everything. Front pages, flashcards, if you want to make it that way. I'd say use a Quizlet, though. So a sample, they said, is a subset of the population we actually study. So a subset of all migraine sufferers. Okay? And then, example, we wish to study whether a new model of a car handles sharp turns well. We select 4 of these new cars from Anderson Auto to test. Okay, I don't know if Anderson Auto is a real place or not. So the population is all of the new model cars. The sample is the 4 cars that we selected to test. Okay? So rather than testing everything, and this is everything we've known so far about statistics, it's important that the chosen sample be a representative sample. The population can be diverse in a great many ways, and everyone in the population of interest should have a fair chance to be a part of the sample. If it's not the case, the sample will almost certainly not be representative of the sample. Okay? So if you guys were the sample, or if you guys were the population, every one of you would have an equal chance of being selected. But like if I were to sample this class, if you guys came to me as a random population, I would then randomly select from the random sample 5 of you to, or some number that would work. Okay, bias, the systematic tendency of sampling method over or under predict the population parameter. Okay, so the population parameter is basically the average, okay, or the mean. Remember, we don't always know what the parameter is. We just, by doing some observations before we do it, we think that, like if you're checking gas mileage on cars, or if you're looking at migraines, gas mileage on cars, you drive a couple of these cars, you realize you're getting like 34 miles per gallon. Migraine sufferers, hey, I noticed that these people who are ingesting these wild grown asparagus plants. By them eating it, there's something in the asparagus that helps them get rid of migraines. Okay. In the real world, bias is considered a form of unfair treatment or manipulation. In statistical world, it means something a little less insidious. It simply refers to a method the data collection was consistently either over or under predict something we were trying to estimate. Okay, so I know most of you probably drive to school. So would it be fair if I went out to that parking lot on the other side of the swimming pool and just sampled people who drove to school over that parking lot? No, because there's other parking lots, right? No. Heck, some of you might even stash your car in a neighborhood that's close to here. I don't know. All right. So, for example, let's say I'm conducting a survey to see who favors raising taxes for public school education. I stand at my local grocery store and ask people that pass by. The result consistently shows that 37% favor raising taxes for public schools and education. However, when the actual vote is tallied, 53% actually favor raising taxes for public school. What happened? Well, you only went to one location. You were just, even if you randomly selected people at that one location to push it out to, like in our case, the entire school district, people over here might be more in favor of raising taxes for their schools. I mean, your families have done great justice for your education because your families feel that education is important. There might be places or pockets of neighborhoods that, you walk into a huge retirement community, say, hey, would you like to pay more taxes for education? Those old people are, no. Okay, Surprise, Arizona. It's actually a town. It's called Surprise. It's a huge retirement community, but you have a handful of schools that are in this community. They can't raise taxes to save their life. Anytime they put to raise taxes on the ballot, they get shot down. They can't, I imagine those kids, that their teachers probably still have chalkboards. You guys have probably never seen a chalkboard other than at home when your parents watch a chalk and a chalkboard, if they did that. So perhaps the grocery store was in a neighborhood with many older residents who may not have as many resources to do in children in schools. My survey was biased, not because I was trying to manipulate the data or because I have some nefarious intent, but because I chose a sampling method that was non-representative. Okay? So where people find statistics, and you guys know this very well because you have been brought up in the age of technology. There's nothing wrong with that. But you know as well as I, if you heard that chocolate ice cream was good for you, I bet you could find a study someplace that finds that chocolate ice cream is in fact good for you. Okay, does it mean it's good for you? No, the internet's full of all kinds of stuff. Some of the stuff is true, some of it is misleading. Okay, bias can emerge from a non-representative sample. Okay, hey, you seniors, who would you want to vote for? Like, let's say there was 3 options for where, I know they've already chosen where prom is, but let's say they didn't know where prom was going to be, and they gave 3 options. Do you want the freshman class voting for where prom is? No. No, why not? They ain't going. Right? So there is a considerable amount of bias in that kind of situation. Okay, random sampling, any sampling method in which everyone in the population has an equal chance to participate. So if I wanted to sample the senior class to find out where prom was going to be, and I realized, oh wow, I have close to 1,000 seniors. It's going to be hard to reach all 1,000 seniors, but every senior, I'm going to pick 10 seniors randomly. Every senior here at Cherry Creek High School should have an an equal chance of being selected to go to vote for where prom should be. Okay. Now, you all know as well as I. If your vote wasn't the vote that you wanted for, if you were like, if you had locations A, B, and C, and you really wanted location B, but because of the random sample being chosen was C, people are going to be frustrated. It's like, well, that's not how I would have voted. And it's like, I'm going to ask all my friends. Well, that's not a good way of sampling. Okay? So random sampling is inherently unbiased and gives the entire population with all the diversity it has a chance to be represented. Of course, random samples can produce variability. Okay? It sways from what you might have thought. Okay? No two samples will be alike, and no two samples will produce identical outcomes. Okay, so if I randomly sampled 10 seniors, and they voted, and let's say 7 of those 10 chose location A, and then I did it again with another 10 random people, or random seniors here at Cherry Creek High School, and then all of a sudden, oh, I see that location B only had 4 of those seniors that chose. I can keep doing it, and it changes each time. So there's some little bit of variability as you do it over. No two samples will be alike, and no two samples will produce the identical outcomes. If I were to conduct a survey to see whether people favor raising taxes for public school education, and I asked 2 people, I could easily obtain 0%, or 50%, or even 100%. Okay, so is 2 enough? I don't know. I mean, we kept saying the sample size needs to be 30. There's also another one that you want your sample size to be 10% of your population. So here at Creek, I mean, was there like 900 seniors? So that's like 90 people in that situation you should randomly sample. Sample sizes that are highly variable and unpredictable and do not provide reasonable estimates. Our best defense against variability is large sample sizes. Okay? We've all been out with our friends. Hey, let's go get something to eat. Okay. And if there's 4 of you in the car, someone's going to be like, dude, let's go to Red Robin. Nah, I want to go to the Burger King. Okay, you could have 4 different people decide. Basically, the person who's driving might actually dictate that. Finally, there are 2 new terms that we'll learn to use. Population parameter, a measured characteristic of a population. Usually, this is unknown. Okay, so if I had locations A, B, and C that we were going to vote on to use prom, I would imagine A, B, or C would have to be the answers, but I can't necessarily, other than, if I'm talking to people saying, hey, we have these 3 locations for prom, I know that I'm going to conduct the survey, people are going to come and go, oh man, location B would be awesome. Okay, that's cool. And I'd walk down the hall and say, hey, you're the one that's doing the thing for prom, right? Yeah, man, I think location A would be awesome. Oh, okay. But I'm just sharing that information. I don't know what people would necessarily vote. Okay? Sample statistic, the measurable characteristic of the sample. This is calculated directly for the purposes for estimating the population parameter. Again, the population parameter is the actual mean or the average of what we're looking for. All right, for example, a researcher may be studying the percentage of all Denver residents that use city biking trails. A survey of 50 Denver residents shows that 28% use biking trails. The population parameter is the percentage of all Denver residents that use the biking trails. The sample statistic is 28%, what we found from our sample, which is the percentage of our sample that uses city biking trails. It is the researchers' hope that the sample statistic is a very good estimate of the population parameter. If I go and want to know, if I want to go collect data on people who are using the biking trails, does it make sense that I go out to a biking trail and start collecting data and say that that applies to the rest of Denver? No, because I'm out in a situation. If I were to send out a ballot to, I don't know, 100 different residents that has a self-addressed stamped envelope saying, do you use the biking trails, yes or no? And all you have to do is write a yes or no, put it back in the envelope, seal it, and go back. It's very possible that the 100 randomly selected people I sent out might not do it. they will actually do, for sample statistics of randomly selected people, they'll put like a dollar bill in there with the hopes that the dollar bill will actually entice you to actually do what was asked. Check yes or no, put it back in the envelope, put it back in the mailbox. I mean, I kid you not, that's stuff that they actually do. There are plenty of times like, I'll open an envelope, hey, here's $1. Oh, thanks. No, recycle the envelope. I just got another $1 to my name. Okay? And that's how a lot of people will run through just life, which is just how it goes. All right, so is that okay for chapter 8 so far? All right, so what we will do, and we will collect this tomorrow after we go over it, is 8.1. So this is on page 145. So try that. See how you go. We'll go over it, and I'll collect it tomorrow too. So some points. I think there will be a quiz and a test this chapter. That's all I have planned. Sound all right? And then you have your final exam. Questions about the final exam?